Right, my peeps, I'm going to do a couple of the review problems. Let's see if you want to check them. All right. So the directions says use the following sequence to answer questions 1 through 6. So what I want to figure out first, before I even answer any questions, is how do I get from one term to the next? Okay. And this is pretty simple. As you can see, we're not adding 4 because when you try to add 4 here, it doesn't work. What we see is we are actually multiplying by 4. And in this problem, it's pretty simple to see. Okay, we're multiplying by 4, which means we have a common multiplier. Okay, because we're multiplying, this makes this a geometric sequence. And because it's geometric, it helps you figure out what formulas you're using, what the graph would look like. All right. So once we got those two statements down, or two things down, that we know that we have a common multiplier or common ratio, the guy you're multiplying by, which makes it geometric. So now we could really do the next 4 terms. So just with your trusty calculator, I'm going to start at number 64. Okay, because it's my last term here, so I'll start at 64. And then I'll write the next 4 terms in blue. And all we're going to do is take our calculator and multiply them by 4. So 64 times 4, that gives me 256. And then we're going to go 256 times 4 again, 1024. 1024 times 4, 4096. And then 4096 times 4, that's 16,384. Okay. So these are the 4 blue next 4 terms in the sequence. All right. Pretty simple there. Hopefully that's not too bad. Number 2, describe how you go from one term to the next. Very simple. We already did that. We multiply by 4. All right. Number 3, is this sequence arithmetic or geometric? We already know it's geometric. We just talked about that. And how do we know? Because we have a common multiplier or common ratio. Okay, which is in this case 4. What is the recursive formula for the sequence? So if you remember, the recursive formula involves 2 parts. We're going to do the function form. So we have f of n. And when we're doing recursive, it always starts with function and then n minus 1 in parentheses. And then here we put what we're doing, and we're actually multiplying by 4. So we put our common multiplier, so we're multiplying by 4. Okay? And one more thing, because it's recursive, we need to let everybody know what's our first term. So if you look, our first term up here is 1. So we write our first term in this sequence is 1. So this entire thing is the recursive formula. All right, what is the explicit formula? So explicit formula, we're going to do it in function form. So f of n equals, and again, this is the geometric formula, so you got to make sure you understand the difference between geometric and arithmetic. There's 2 different formulas here. But we're using the geometric, which says take the first term. Okay, which is 1. So I'm going to put 1 here. Then we're going to go ahead and write in this case, since it's geometric, we're going to write in our common multiplier. So in this case, what are we multiplying to get to the next term? We're multiplying by 4. So we're going to go times 4, and then the formula says calls for an exponent of n minus 1. And there's our explicit formula. So now we want the 12th term of the sequence. Well, to do this, I'd rather use the explicit, okay, because all we have to do is plug in the number 12 and do the math, and we get our answer. If we try to use the recursive, we have to find all the numbers until the 11th term, and then we use the 11th term to get the 12th term. So this is a faster formula here. Okay, so we're going to plug in 12 in for n. So it's going to be f of 12 equals 1 times 4, 12 minus 1. So order of operation says, let's go ahead and do the exponents first. So it's going to be 4 to the 11th. So let's throw 4 to the 11th in our calculator. Okay, this is a giant number, so it's going to be f 12th term 1 times 4,194,304. So now we're going to multiply 1 times this, and that's pretty simple to do. Our 12th term is 4,194,304. Okay, and that's how you do that section. Okay, let's do a couple word problems. Let's start with number 7. So instead of giving you a sequence, they're giving you a scenario here. So he's going to start with $2 and double that amount each month. Okay, so let's show some work here. Okay, so we start, so let's use that. We start with $2. So let's pretend this is first month, and then we're gonna double for the second month, and so on, the third month, the fourth month. Okay, so in the second month, doubling means we're gonna multiply. To double something, you multiply by 2. Okay, so that means a second month we're gonna be at 4. And then the third month, again, you're doubling, so we're just going to multiply by 2. And that's going to give me 4 times 2 is 8. And so on. Okay, we're going to continue this all the way through. 8 times 2 is 16. And then we do it one more time because we want the first 5 terms, or the first 5 months. Times 2, and that gives me 32. So we are multiplying, which tells us, I'm going to put it up here as a little note, this is geometric. Okay, what is the explicit formula for Mr. Brust's sequence? So remember, we're using the explicit geometric. So let's call it B for Mr. Brust. So the sequence B of n equals, and remember the formula for geometric, check your notes if you forgot, is we want to put the first term here. In this case, $2 or 2. And then after that, since it's geometric, we're going to put our common multiplier. In this case, it's 2, so times 2 for the common multiplier, and then we throw n minus 1 as an exponent there. Okay. So who will have more money after 1 year? Explain how you know. Okay, so let's check for Mr. Brust's. So in 1 year, Remember, we're going by months up here. So how many months are in a year? So we're checking for 12 months. So that means we're going to use the explicit formula, and we want to know how much money he has after 12 months. So I'm going to plug in the number 12 here. And we're going to do this math. So it's going to be 2 times 2, 12 minus 1. Okay, so take out your trusty calculator now. And after 12 months, we get 2 times 2 to the 11th. So we're going to go 2 to the 11th power. And that's going to give me b of 12 equals 2 times 2048. And do that math. 2048 times 2. So after 12 months, Mr. Bruss will have $4,096. Okay? So now we know what he has. We want to see what Mr. Bean does. So we'll put his work in blue. Okay? So let's figure out what Mr. Bean's sequence looks like. So he's going to start with $800. So on the first month, month 1, so first month, just like we did before, $800, and then to get to the next month, he's adding $1,200 each month. So that means we are going to add $1,200 each month. Okay, so let's figure out what that is. Okay, so that means we are going to have on month number 2, 2,000. So the second month we have 2,000, and we're going to continue this, and we want the first 5. So 1, 2, and then the first 5. So let's figure out the first 5 months. Okay, and this is 1,200, adding 1,200 again. $3,200 for month 3. Plus 1,200. We got 4,400, 4,400. And then one more month. Plus 1,200. And we got 5,600. Okay. All right. So we'll go ahead and do the explicit formula. Since we're adding, we know that our formula is going to be arithmetic. Okay, so we're going to use the arithmetic formula for this. So we'll call Mr. Beans, we'll call him function G. We'll just call it G. So G of n. And in the arithmetic, we again want to put the first term. We know the first term is 800. And then we want to put what's our common difference, or what are we adding? So plus 1,200, and then the formula calls for multiplying by n minus 1. Okay, so this is actually the explicit, but I'm going to clean it up like I showed you before. So I'm going to multiply this in to simplify it out. So it's going to equal 800 plus 1200n, because we're distributing, minus 1200. And then we want to combine these like terms. So 800 minus 1200, we're going to get 1200n minus 400. And this is the simplified explicit formula. Okay, so this is kind of the nice one we want to have, but both of them are correct. Just remember, when you do the multiple choice test, you might have either the long one or the cleaned up one, so you got to check for both. All right, so after 1 year, what is Mr. Bean's total going to look like? So we are going to plug in 12 because there's 12 months in 1 year. So G of 12. I'm going to use the cleaned up version, equals 1200 times n, which is 12. And we're going to minus 400. All right, so let's do this math really quick. 1200 times 12. So after 1 year or 12 months, we have 14,400 minus 400. Okay, which means Mr. Bean's total amount after 1 year is going to equal $1,400 or $14,000. So by far, Mr. Bean's method would be the better method to raise money. Okay. All right. So the rest of the review problems are very similar to these two. I just wanted to go over a couple. Make sure you're comfortable writing some formulas. All right, good luck on the test.